Okay, so lesson 4, we're going to revisit area. But this time we're going to have, we're going to actually want to find area between two curves, which is a little different than what we looked at before. Sorry about that. So looking at example 1, example 1 says to find the area of the region bounded by y equals x squared and y equals 2x plus 3. And that's all we're given. You have to know what these graphs look like. You have to determine the intersection. So luckily we're given two functions that we're familiar with, and I will draw them very sketchy. So y equals x squared, and I'm going to do that one in blue. Y equals x squared looks something like this, and y equals 2x plus 3 is going to look, something like this. Okay? And that's the only information that we're given. So previously, when we were finding area, we only had one function, but we had some parameters that it had to fall, that it was bound by the x-axis and perhaps a couple of x values. So here's what we can go ahead and kind of talk through this a little bit. The area equals, we know we have to have an integral, and if I need the region, the area of the region that is bound by these two graphs, we're talking about this region right there. So the question is, how do you find the area of that particular region when you have two functions? Well, let's just say that we didn't have the quadratic. We would find the area under this curve. So everything in red, would be, under this curve. Well, if this right here represents the area under the line, and I only want this portion right here, then what can I do to find that area? Well, if I find this area, or if I need this area, what I could do is find the area under the curve of the quadratic. So I could find, this area under the curve and then subtract. So what does that look like? Well, that's going to look like this. I need to subtract. So I'm going to take my first function, x squared, and I will subtract the bottom function, which was the quadratic, and I've so written this backwards. So the area will be the top function minus the bottom function. And that will give us the area of just this little portion in here. Okay, so top function is 2x plus 3, and I need to subtract the bottom function, which is x squared. And since I'm working with an integral, I need my dx there. Now, what do you suppose our lower bound and our upper bound are going to be? How do we determine those? Well, they're going to come from the intersection of those two functions. So we need to find the intersection points. So how do we do that? We set those functions equal to each other and solve for x. So x squared equals 2x plus 3. I will subtract all of this over to get the quadratic all on one side. And I will factor. And when I factor, I'm going to put a 3 here and a 1 here, minus and plus. Yeah. So I get two intersections, one at x equals 3 and the other at x equals -1. So this is the -1 and this is the x equals 3. So our lower bound will be -1 and our upper bound will be 3. So we've got everything we need, and we can find the area that is bound by those two curves. All right, and so to do that, the antiderivative of 2x would be 2x squared over 2, which is x squared, plus 3x minus x cubed over 3. And I will evaluate that from -1 to +3. And when I do, lovely, it's going to get kind of ugly, but that's okay. 3 squared plus 3 times 3 minus 3 cubed over 3, and I will subtract 1 squared plus 3 times 1 minus 1 cubed over 3. And cleaning this up a little bit more, we're going to get, this is 9 plus 9, and that actually turns out to be minus 9, minus 1 minus, you know what, that's not right. That's not right because that's a -1. So, pooey. -1 there, -1 there. That part was right. That portion was right. This portion was not. So I still have my 9 plus 9 minus 9 minus the -1 squared is 1. 3 times -1 is minus 3. And then minus the 1/3, 1 over, that's actually going to be a plus 1/3, because when I substitute -1 here and cube it, that's -1, and the negative out front makes that +1. Okay, so when I go about cleaning the rest of this up, we get 9 plus 9 is 18, minus 9 is 9, minus, looking at all of these in terms of over 3, that's 3 over 3, minus 9 over 3 plus 1 over 3. That'll be -6 over 3 plus 1 over 3 is -5 over 3. And then 27, I'm going to look at 9 as 27 over 3. I don't know why I didn't put my 2 there, but I have 27 over 3 plus 25 over 3, which really gives us 52 over 3. So the area of this region right here that is bound by the two curves is 52/3. And 52/3 is, I don't know, it's approximately 17.333-ish. So that would be the area that is bound by those two curves. Okay, so when you're finding area, it really, really, really is helpful when you know what the graphs look like. Okay, so now looking at a different example, let's see what we got going on here. Next example, it says find the area of the region bound by y equals e to the x and y equals x, as well as x equals 0 and x equals 1. Okay, so graphing this, y equals e to the x is an exponential function, and y equals x is a line. It's the mom and daddy line. The other pieces, though, tell us that we're also, these two, the region is going to be bound by x equals 0, which is vertical, which is here, and x equals 1, which I will say is here, okay? So the region we're working with and wanting to find the area of is this little piece right in there. So, these two graphs, the two functions themselves do not intersect. But that's okay. We have what we need in order to determine the lower and the upper bound. Our lower and upper bound are going to be 0 to 1. So to find the area, lower bound is 0, upper bound is 1. My top function is e to the x minus my lower function, which is x, and then I just need to integrate that with respect to x. So here we can continue. The antiderivative of e to the x is e to the x. The antiderivative of x is x squared over 2. And I will evaluate that from 0 to 1. So, e to the first minus 1 squared over 2 minus e to the 0 minus 0 squared over 2. Okay, so this is 0 right there. E to the 0 is 1. So what I have now is I have e to the first, which is e, minus 1/2 minus 1, which ultimately cleans up to be e minus 3/2. So the area of this region, and because this is a no calculator question, you do not have to convert that to a decimal. You can leave your answer just like this. There's no reason to try to do anything else with it. Okay, now our next example, even though this year, 2020, you're not going to need or have a calculator specific question, I still want to go through this with you guys. So the first example, or the first equation that we have, or function, is y equals x over the square root of x squared plus 1. And the second one, y equals x to the 4th minus x. Okay, so I'm going to pull up, I want us to look at the graph of this. And it just so happens that I've already put the equations in my y equals. I've already set a window, and so here comes the graph. So I have the blue graph. The blue graph is the square root function, the function that involves the square root, and the red graph is the 4th degree function. So the top function is the blue, and the bottom function is red. And what we need, what we need is the intersection points. So we need this point and this point. So how do I set up my area, or my formula, or integral? The area will equal, I'll get my lower bound and upper bound in just a minute, but I know I'm going to have this set up as x over the square root of x squared plus 1 minus, please be careful, this function has 2 terms, so therefore we have to use parentheses, x to the 4th minus x, and all of that, and you will be, the integral needs your dx there. Okay, with this being a calculator active question, you do not have to do anything with this. You do not have to clean it up. You will not have to find the antiderivative. You just have to show the setup. Now, what I haven't done is I need to find that lower and upper bound. So I need to find this intersection point. And quite frankly, it looks like it's at 0, but I'll let the calculator tell me specifically if that is. So how do I go get the intersection? So you want calc, so it's second trace. I'm going to choose number 5, which is intersect. And I'm going to move my cursor close to the intersection. I'll push enter for first curve, enter for second curve, and enter for guess. And I was right. The lower bound is at 0, 0. They intersect at 0, 0. So my lower bound is going to be 0, or my lower boundary is going to be 0. Now for the upper boundary point, I go find this intersection. So second calc, I'll choose number 5 again. I need to move my cursor over to the intersection point, closer to the intersection point, and I will push enter for first curve, enter for second curve, and enter for guess. And now my upper bound is not quite as nice of a number, and you want the x value. So that's 1.1807757. Okay, so now we have everything that we need to find the area between those two curves. All right, so you have your setup. Now we're going to let the calculator do all of the work for us. So I like to approach it this way. I'm going to quit and go home. I'm at my home screen. Now I know that I put this equation in Y1. I know that this equation is in Y2. Y1, Y2. And this is what I really love about this, the technology part of this. So I am going to go to math. Oops, I'm going to scoot this up and over. So I'm going to go to math, and I'm going to choose number 9 because I'm wanting to integrate. And now all I have to do is type in a little information and I'll have my answer. My lower bound is 0. My upper bound, please do not round your number here. Never round your answers or chop them off in the middle of the problem. Save that always till last. So I'm going to type in 1.1807757. I'm putting it in there, all of it in there. I'm going to use my right arrow key, and now I'm inside the parentheses. Well, I don't want to type this again. I've already typed it once when I looked at the graph. And so where did I put that? I put this function in Y1. So I need to tell the calculator that's where it is. So I'm going to vars right here. I am working with, I need to go over to yvars for y variable. I'm working with a function. I now found y1. And now I'm going to subtract the red function, or the bottom function, which I put in y2. So I'm going to do the same thing I just did. I'll go to vars. I'll go over to yvars. It is a function. I'll choose number 2. Now there's one more piece of information I have to put there. And I have to finish that off with an X. So using my X key, boom, there it is. I'm ready to push enter, and there's your area. So the area of that region is 0.7853. Now we don't have any units, so you just leave it as 0.7853. And there it is. When it's a calculator active question, it's very important. It's so important for you to show the setup of the integral. You have to show your intersection, your lower bound and your upper bound, but you can let the calculator do all the calculations and show your answer. On an on a free response question like this that's on the calculator active portion, if you did not, if you were to just do this, oh, here it is, and just put down for the answer 0.7853, that's what I call a bald answer with no work. That would get you 0 points. You have to show the setup. It's so very important. Okay? All right, so I have one more example for us to look at, and it's a little different, but the process is the same. So my next example starts out by saying, okay, find the area that is enclosed by y equals x minus 1 and y squared equals 2x plus 6. Okay, so we have a little situation here where we know that this is a line, and if you're on your toes, you'll know that this actually is a parabola. The graph would be a parabola that opens to the right. Okay, so the issue here is this does not represent a function, and I need it to represent a function. So here's what I'm going to do. I know that I'm gonna sketch out what I think I know this graph to look like. Well, let me do this first. I'm going to graph. I know that this is a parabola because there's two variables, an x and a y, and only one of the variables is squared. So to write this in, quote, function form, which I really can't, I want to get x by itself. When I get x by itself, I'll subtract 6, and that gives me 2x equals y squared minus 6. And now I'm just going to go in and divide everything by 2, which gives me x equals 1/2 y squared minus 3. So what that tells me is, this gives me a little bit better idea of what this looks like. So here's what our graph looks like. I have a line that is defined by y equals x minus 1. So I have a y-intercept down here. Slope is positive 1. So my line is going to look like this. My parabola, because I solved this for x, and my y squared term is positive, I know that my graph is going to open to the right because this is an x equals, and because y squared is positive, I know it's going to open to the right. I also know that this minus 3 is going to take the parabola and shift it backwards 3 units. So my graph is going to look something like this. Okay? So here is my parabola, which is defined as x equals 1/2 y squared minus 3. And my line, I drew my line according to y equals x minus 1 because it was easier. But if this equation is in terms of x, this equation needs to be, let me say that again. If this equation is x equals, and it's in terms of y, we need to do the same thing here. So if I want to get x by itself, this one's pretty simple. X equals y plus 1. So x equals y plus 1. Okay, so we have our two equations. We need to know the intersection of the two. So setting the two x equals to each other, this one and this one, notice what our variables is. I'm going to take my y plus 1 and I will set it equal to 1/2 y squared minus 3. I do not at all like working with fractions, so I can multiply this entire equation by 2, and I get 2y plus 2 equals, the 2 times 1/2 will give me 1 y squared, and then the 2 times negative 3 is negative 6. So now my quadratic looks a little bit better. I'm going to have y squared, subtract the 2y over, subtract the 2 over, and that'll be a minus 8 equals 0. And now I can factor, and that gives me y minus 4 times y plus 2 equals 0. So my intersection points have y values of 4 and negative 2. So notice there's some differences here. We have everything we need. So, but I want to talk about the differences as we set up our integral for finding the area of the region that is bound by those two curves. So, our area, our variable, the variables in our expressions are y variables. When we find the lower and upper bounds for the intersection, those will be the y values. These two are y values, so that's good. We know our lower bound will be -2 and my upper will be 4. So this is your -2 and this is your +4. But here's where you have to pay attention and be careful. Because our y values, because our integrand is going to involve y values, we don't subtract top minus bottom. We subtract right minus left. So what is that going to look like? Well, if you look at this way, your rightmost portion of the intersection or of the bound or of the region is your line. So we start with y plus 1. We will subtract the leftmost or the left portion or the leftmost function of the region, which is going to be 1/2 y squared minus 3. So when your variable that you're working with, when your integrand involves the y variable, there's some things you've got to kind of be careful with, because the variable here is y. We multiply by dy. Our lower and upper bounds are in terms of y. And when your variable is y, you always subtract to find that area right minus left. Okay? So let's go about cleaning this bad boy up and see what we get. So I'm going to clean this stuff up just a little. -2 to 4, and that's y plus 1 minus 1/2 y squared. That's a +3 dy. I'll do some more cleaning up. I have y. I'm going to do the minus 1/2 y squared, and the 1 plus 3 is 4. And all that's dy. Oops. And that goes from -2 to 4. Now I'm ready to find the antiderivative. I'm going to scoot that up some. And that's going to be y squared. Yeah, y squared over 2 minus, okay, that's going to be y cubed over 3. So there we have that piece. And then plus 4y. And all of that needs to be evaluated from -2 to +4. So I'm going to come way back over here, and to show the substitution, that's a 2. I'm going to have 4 squared over 2 minus 4 cubed over 6. You have to multiply those two together, plus 4 times 4, and I will subtract, substitute -2 squared over 2 minus -2 cubed over 6 plus 4 times -2. All right, well, that gets a little on the nasty side. So I'm going to let you guys finish all that out. And when you ultimately do, you ultimately get an answer, I believe, of 18. So here's what you have to determine. You have to determine what the region, what your region looks like. What does that bounded region look like? And you have to decide, do I need to use my equations in terms of x equals or y equals? If your equations or if your expressions deal here with y's, your lower and upper bound have to be in terms of y, and you always subtract right minus left. For equations when your variables here are x's, your lower and upper bound need to be in terms of x, and you will subtract top minus bottom. Okay, so that is how you would find the area between two curves. And the idea is making sure that you get the correct sketch of your graph, because if you mess that up, then your whole problem is messed up. So anyway, that's it for lesson 4.